Starting with first problem of the day, let me share it. Okay, this is one very standard problem, and it was actually repeated in one of the interviews of ServiceNow. So the problem is you are given a string. I assume everyone knows about palindrome, okay, because that is the basic requirement here. And you have to find the longest substring, which is a palindrome. Okay, so tell me your approaches for solving this particular problem. You can assume, okay, start with brute force one, then tell optimized also. So palindrome is a string which is same from left to right and right to left. Same in the sense you compare both strings. First string from left to right, you compare with the second one you get if you reverse it, or if you see the string from right to left, they need to be same. So we have like geeks, SKEEG, like they are together forming a palindrome. Similarly, EE is also a palindrome. So how you will find longest substring which is a palindrome? Okay, Yamini is saying using nested for loops to find the substring and send that substring to a function and check for palindrome. Find the length if length of it is maximum. Find the max length using max function. Okay. You have to print the substring. Okay, okay. So you will compare all the substrings. Like if they are palindrome, you will get some length and you will keep on comparing the length. If you find a substring with more length or greater length, you will update your maximum length till now and get that substring as longest. Okay. But here you are using nested loops. So what would be the time complexity, Yamini, for that? Is it O of n square? Because nested loops is O of n square, but after that you have to compare also. Is your string palindromic or not? And I think comparison will take additional n operations. So I guess it is O of n cube, n square for generating all the substrings, and then one additional n for checking if I have a substring, how to check if it is a palindrome. That will check additional n operation where n is the length of substring. Okay, so we got one response. I'll use my whiteboard. Right. Problem is very clear. So you are given a string S. You have to find longest palindromic substring. Palindromic substring. Substring is nothing but subarrays itself. Okay. But when we are talking about strings, so subarrays is nothing but substring. Okay. Substring we have continuous characters together or a part of continuous characters from our original string. Okay. So what Yamini said, suppose I have something like this. This is suppose my string. This is the longest palindromic substring that is possible. So answer I have to actually print this. Okay. How I am printing this? First I am generating all the substrings. How to generate? A simple clue I'll give. Suppose I have a string ABC. Now how you can find all the substrings? First you'll try to find all substrings which are starting with A. So all substrings which are starting with A is A, AB and ABC. All substrings after that you will find all substrings starting with B. So we have B and BC. After that we have C. All substrings which are starting with C. Okay. So these are all the substrings which are possible for string A, B and C. String ABC. Okay. Now how we actually do that? We use two for loops. One is nothing but starting index of your substring and other is going to be the ending index of your substring. Okay, remember always when I am at index I, my ending index is always starting from I itself because first substring is substring of length 1 which is nothing but character present at ith index. Okay. String formed by only one character. Okay. So J will start from index I and till where it is going. So if I write their indexes, we have 0, 1, 2. This substring is formed and the range of values or the ending points are like this. Starting point is 0, ending point is 2. 2 is nothing but last index, very last index which is valid. So J is going till very last index plus J. Okay. So you can take one variable temp or let us write it as substring subs. Initially it is going to be empty. Okay. Because initially when we are starting from any index, what is our goal? Our goal is to find all substring starting from that particular index. Okay. So initially there will be nothing. I will have empty substring. Okay. Empty string. Okay. Now, as I proceed, I will take those characters. First, if I take character present at index j, so what will happen? I'm adding one character in my substring. So I'm getting a new substring. Okay. Initially, when I'm starting, suppose from index I equal to 0, initially my string is empty, substring is empty, there is nothing in it. When I take this particular value at index 0, I get this string, okay, which contains a. So whenever I'm adding any character, I'm getting a new substring. So after that, you will have to check for palindrome using some function, okay. So you created one function where you are passing a string and you are checking if it is palindrome or not. So obviously it is going to be a Boolean function. So if it is a palindromic substring, it will return true. Then you'll consider the length and update your answer also. You'll do something like this. Okay. Now, what is the catch here? How many operations you are doing? N operations in outer loop, N operations in inner loop. And for checking a string, if it is palindrome or not, you have to perform N operations. So it is N into N into N, which is like N cube operations you are performing. And time complexity will also be O of N cube. Okay. So this is a N cube solution where we are finding all the substrings and checking every substring. Okay, I'll write this. So once I'm checking a substring is palindrome or not, I'm passing a string. And basically, I'm passing the substring I am having currently. Okay, if it is a palindrome, it will return true because I have created, suppose, a Boolean function. Boolean means either the value can be true or false. So I will have some length. Length of substring will be subs dot length, and I will maintain one variable, like I'll maintain two variables. What is the maximum length till now? Initially it will be 0. And what is the substring that I got? Or let me write final substring, or it should be longest substring, L sub. Initially it will be empty. Okay. So I'll compare if length of my current substring, which is palindrome, is greater than maximum length of substring, palindromic substring till now. So it means I got a substring which is greater in length and also a palindrome. So I have to update my maximum length here. And also I have to update my longest substring, longest palindromic substring. Okay. So this is what you will do. I guess you can create this palindromic check function. Very easy. You can keep iterating and keep comparing first and last element. If they are equal, you'll decrement end point and increment starting point and so on. You'll keep on comparing all those characters. Okay. Now my question is, can we optimize this? Answer is yes. I am expecting answers from you. Tell me more optimized solution of this. More optimized means I am currently solving the problem in O of n cube time. I want to solve it in better than O of n cube, like O of n square. Think about O of n square. A hint for optimized approaches. Very simple. We have two types of palindrome. One is odd length, other one is even length. And it has something to do with the midpoint of palindrome. Okay, we got one response from Misha. Palindrome equal to s dot substring from 0 1 I 0 j is n minus 1 while I less than equal to j. Current equal to substring from I to j minus I plus 1 from I to j minus I plus 1. Okay, Isha, isn't it the same? First, you will get the substring in linear time, like it will take n operations for getting the substring. Then for checking them additionally, okay, I guess you are not looping twice. So, okay, if it is a palindrome, you are doing j minus minus. You'll miss some test cases, Isha. Suppose I have a substring at the end. So suppose I have something like this. We have A, B, C, and we have A. So what you are trying to do is you are checking substring for this part. If it is a substring, great. If it is not a substring, you are decrementing the value of j, something like that you're doing. So we will miss this particular part in that case. If j is decrementing after every operation, so we'll lose this. Okay, this problem should not take much time because it is very standard problem. So here is the hint. Suppose what was the first string? It was for geeks for. Okay. So I have a string like this. Now for odd length substring, odd length palindromic substring. In case of odd length, we have one example like this. Then we have one example like A, B, A, D, D, something like this. So in case of odd length substrings, we have only one midpoint. Okay, or it is exactly same about midpoint. This is the midpoint. So it's more like mirror image. Okay. So we can utilize the same concept here. For every index, I will check or I will consider it to be midpoint. Okay. I'll consider it to be midpoint. And since what is the property? They are exactly same about the midpoint, both parts. Like we have a left part, we have a right part. They are absolute mirror images of each other about midpoint. Okay. For odd length, for odd length. Okay. We have seen this example A, B, A. So we have this, suppose B is the midpoint. So left part and right part are going to be exactly same or mirror images of each other. Okay. So how many indexes we have? We have n indexes. If I have to check what is the length or the longest substring I can get, longest substring, longest palindromic substring I can get, if I consider my current index I as midpoint. My goal is to find this thing. Obviously, if I have certain odd length substring, then I can eventually find that because one of the index will be the midpoint. Okay, I'll take this example. I have something like this, and here length of longest substring, which is palindrome, is this. So here, this particular index will serve as midpoint. So your midpoint is going to be one of the index of your substring. Okay. And you'll keep on comparison about the substring itself in both the parts. Okay. So this seems more optimized. Why? Because we have only n midpoints which are possible, because we have n indexes only. And for every index, we cannot have more than n length palindromic substring. So number of operations you will be performing is n into n, which is n square. Okay, this is one part. This is part one when we want to find what is the longest odd length palindromic substring I can have. Goal is very simple. I'll take this string only F D C B C D E X. F D C B C D E X. First, my index I is 0. I'm considering this to be midpoint of my palindrome. Okay, I'm considering this index to be midpoint. Now, if this is midpoint, obviously, length will always start from 1, and my current substring, let us don't focus on that. Let us focus on starting index and ending index and length. Eventually, when we will have the starting index and ending index of longest substring, we can generate the substring itself. Okay. So let us focus on starting and ending point of the palindromic substring at as of now. Okay, so we need 2 points. Okay, one will move in left direction, one will move in right direction. Okay, so I can write L as I minus 1. Wait. We are missing out one thing. L is going to start from index I only, and R is also going to start from index I. Okay, because we have to consider this index also. What we are saying is, okay, if this is my midpoint, so I have to consider this character also, no? So currently my substring will be from L to R, or more formally from index I to I only. And that is right because currently I am considering only one character which is present at index I. What is that character as of now? It is F. Okay, so L will be 0, R will be 0 for I equal to 0, and length is 1. Okay, now three more variables I need to consider. One will be storing maximum length, which will be initially 0, which will eventually at the end store the maximum length of palindromic substring that is possible. And two more variables, starting and ending point of the longest palindromic substring. Okay. They are also eventually going to be 0 and 0. So I consider this. First, I check if my current length is greater than maximum length. I will update my start to be equal to L and N to be equal to R. Okay. I'll do something like this. Okay. So this will help me. Okay. I'll update maximum length also, which will be equal to length. So whenever I find a substring which is of greater length, which is palindrome, I'm updating my starting point, ending point, and maximum length. Okay. At the end, I'll have starting and ending point of longest palindromic substring. Now, how we have to proceed? We have to compare elements which are just adjacent to this midpoint. Okay. For F, I'll try to go in left direction and I'll try to go in right direction. Because in palindrome, they are symmetric about midpoints. But there is no left part that is possible because I am at the starting index itself. So I cannot form any substring of length greater than 1 where I is equal to 0 is midpoint. Okay. So as of now, I have a length 1 substring which is a palindrome and which is longest till now. Next, I go to index 1. I is 1. Now I consider character present at index I equal to 1 to be the midpoint. This to be midpoint. So I'm considering this character to be midpoint. If this character is midpoint, then these characters need to be same. If I want to form a palindrome, okay, but are they same? They are not same. So again, I have a length 1 palindrome only, and that palindrome is nothing but containing only D. Okay, so I'll not update my MX start and end. Okay. Next, I go to next index. I index is 2. Sorry, I value is 2, which is pointing at this C. I consider this to be midpoint. Now, once you consider this to be midpoint, you have to compare adjacent character like left part and right part. Are they equal? They are not equal. Okay. So you cannot proceed. You cannot take those characters in your substring and form a substring. Okay. So eventually, I'll keep on moving. I'll move forward, go to this B. Now, when I go to this particular B, my current index I is equal to 3. 0, 1, 2, 3. So what I'm saying, let us consider this index 3 to be midpoint. Okay. Now, my left point is 3. Currently, right point is 3. I compare, is the character present at index left, sorry, left index is equal to character present at right index? Yes, it is equal. So I can consider this character to be part of my substring. Okay. After that, once they are equal, you have to move in both the directions. You'll move in left direction and right direction. Move in left direction and right direction. And compare again. So length was 1. Now I compare again. So left minus minus. This will help me move in left side, left direction. And R plus plus will help me move in right direction. Okay. I compare again. Are the characters at those index same? Yes, they are same. They both are C and C. Okay. So since they are same, I can consider those two characters. So here your length is also need to be modified 2 times. And again, you'll do this L minus minus R plus plus. Once they are same, it means you can form a palindrome of length 3 till now. But are you going to stop there? No. You'll keep on going in left and right and compare those characters until they are not equal. Again, next time what happens? Your L is at index 1, R is at index 5. Are the character at these two positions same? Yes. So again, your length will be modified. You'll update your L and R. Okay. So when you will stop, either there is no more character present on left or right side, or the characters present are not matching. So since these are matching, so it means you can form a palindrome, this particular palindrome where B is the midpoint. This is my B. Okay. Now next again, I will not stop there. I'll try to go left and right and compare the characters. But at the moment, my left character is F, right character is E, and they are not equal. So I have to stop there. I'll come out of the loop. Okay. So here what you are doing, you are considering index I to be midpoint, and after that you are moving in both the directions. Because if you have an odd length palindrome, first we are doing for odd length palindromes. Okay, we are trying to find what is the maximum length of odd length palindrome that is possible. We are going in both the direction because we have a symmetry about midpoint in odd length palindromes. We are checking this character. which are present at I minus 1, I plus 1. Are they same? If they are same, then only we are proceeding forward. Okay, we are going to their left and right correspondingly and compare I minus 2 and I plus 2. Okay, and so on. So eventually for any index I, we cannot have more than n by 2 operations to perform because we are moving in both directions. After n by 2 operations, we will reach the end. So if I take it as n operations, so eventually my time complexity will be n into n. N for considering all the indexes and this particular n when I am moving in both directions of index I. Okay, so this is for odd length. What we observe is, so for odd length palindromes, we have symmetry about midpoint. Okay, we can take any example. This is my midpoint. Simple funda. This and this character are equal. Okay. Next, this and this character are equal. Okay. This is the first character to left. This is the first character to right. So first character to left of midpoint need to be equal to first character to right of midpoint. Next, second character to left of midpoint need to be equal to second character to right of midpoint. Then only you can form a palindrome. Okay, where C or this is the midpoint. That is the observation here. Okay, and I can have n midpoints only because I have n indexes and characters. I cannot have more than n midpoints. So I have n midpoints and eventually I am performing this particular operation and this will take again n operations. I am taking actually it will take less than equal to n by 2 operations. So since n is very big, I am considering it n. So time complexity will be n square. Now my question here is how you will proceed for even length. Because in case of even length, we have two midpoints. I'll take this example only. So this is a even length palindrome. This is one midpoint, this is other midpoint. I'll write left midpoint, right midpoint. So how you'll find this? Is there anyone who didn't understood the last part for odd length palindromes? They can ask. Yes. Okay, let us go one by one. For even length, let us focus on one of the midpoints only. Uh, when LM is equal to RM, we will check LM minus 1 is equal to RM plus 1 or not and continue. Yes, Navya, you are right. It is pretty simple again. There is just one modification. What? Those midpoints need to be equal. Once those midpoints are equal, then you are doing the same task. You are moving in left direction, you are moving in right direction, and checking if they are equal or not. You are moving in right, you are moving in left. So first, these midpoints need to be equal. Once they are equal, then you can start moving in left of left midpoint and right of right midpoint and compare. Okay. So suppose let us focus on left midpoint only. So I can have left midpoint at index 0. Can I have left midpoint at index n minus 1? The answer here is no. I cannot have a left midpoint at very last index. Then there will be no space for right index. Okay. So we are focusing on left midpoint. So your loop will go from 0 to n minus 2. So here your index I is nothing but left midpoint. So it should be equal to right midpoint. And right midpoint is at index I plus 1. So first you will compare element at index I or character at index I is equal to character at index I plus 1 or not. Because I is, you are saying left midpoint, then I plus 1 will be right midpoint. Okay. Once left midpoint and right midpoint are equal, so to get start with, you'll have length equal to 2. If both the midpoints are same, you are getting two characters. So your length is 2. And now you start moving in left direction and start moving in right direction. Left direction of left midpoint, right direction of right midpoint. So your left will start from I minus 1 and right will start from I plus 2. You'll compare those characters. If they are equal, you'll increment your length by 2. If they are not equal, you'll stop there only. Okay. So here there is only one addition. First, you are focusing on one of the midpoints, that is left midpoint. So once you are focusing on left midpoint, it can be any character starting from your first character till the second last character. Your left midpoint cannot be at last character because in that case there will be no room for right midpoint. Okay. So you are having a loop from 0 to n minus 2, and now you have to make sure both the midpoints are same. So if I is the left midpoint, then right midpoint will be at I plus 1. So these two characters at these two indexes need to be same if you want to move forward with looking for even length substring. If they are equal, your length will become 2 and you'll keep moving forward and check for left side and right side. Left side will start from I minus 1, which is left of left midpoint, this character K, and R will start from right of right midpoint. Okay. You compare these characters, if they are equal, you again do the same thing. L minus minus R plus plus. Keep on moving in both direction and compare the characters. Okay. So that is what you are going to do. Here also you are not performing more than n square operations. So that's how your code is now optimized from O of n cube to O of n square. Okay. Anyone have any doubt in logic part? They can tell. I'll write the pseudo code for this. It is very simple. Obviously, we need three things. What is the maximum length going to be? It will be initially 0. And we are trying to find starting and ending index of the longest midpoint. Longest palindromic substring. Starting index, let us say 0, and ending index also, let us say 0. Now, for odd, I'm writing, you can do the same thing, just you have to do comparison between the midpoints first. Okay. So for odd length, you can have all the index, like all the index can be your midpoint. So I equal to 0 to I less than n plus I. So now your length will always start from 1 because what is happening, you are considering element present at index I, or you are just saying this index I is midpoint of your palindromic substring. So if you have only one character in a string, it is a palindrome. Okay. So eventually length will be 1. Okay. And left will start from I minus 1. Right will start from I plus 1. Okay. Now you'll use a while loop. Why you use a while loop? Because you don't know how many operations you have to perform. Okay. You are simply trying to move in both directions, in left direction and in right direction. So you are at suppose index I. So L is at this point. Here we have L, here we have R. So we will compare them. If they are equal, then only we'll move forward in this direction and in this direction. So first they need to be valid. Valid in the sense L need to be greater than equal to 0 because we are decrementing L. So the last valid index in left side is 0. So your left need to be greater than equal to 0 and your right need to be less than n. This condition need to be satisfied. Your indexes, left and right indexes need to be valid. Next thing you compare is, are they equal? If suppose S is my substring, sorry, S is my string. So are these two characters equal? If they are equal, it means you can take them in your substring. So once you are taking them, your length is getting modified by 2. So here I was at B. Now L is pointing at this A. R is pointing at this A. They are equal. So I can have a substring of length 3 now. Okay. Why? Because I got two characters present at L and R. So length is getting modified by 2. And next operation is you'll move forward and check for other characters on left and right side correspondingly. So L minus minus R plus plus. If they are not equal, you'll come out of the loop. Okay, because you cannot take them. You have to stop there. Now, once you come out of the loop, in that case, now what was the last valid index? Last valid index was L plus 1 and R minus 1. Okay, because these were the indexes whose characters were equal. Because if they are equal, then only you are updating and moving on to a left and right character of corresponding. Sorry, you are moving to left and right characters correspondingly. So this is the last valid index which you took in your substring. Okay, palindromic substring. So this can act as your starting point or ending point. Okay, I'll write the rest in next page. Those who want to take screenshot, they can take the screenshot of this. Okay, So once you come out of the while loop, you have to check with the length. Is my current length of substring, palindromic substring, greater than maximum length of substring that is possible? Maximum length of substring that I am having at now, till now. So you will update your maximum length. Okay. And your starting and ending point is also going to update it. Starting point will be L plus 1, ending point will be R minus 1. Very simple. We'll take this example D, A, B, A, D. Here, suppose this is my midpoint. I is index 2. So L is at index 1, R is at index 3. So I compare and length is 1. I compare these two characters, they are equal. So my length is getting modified to 3. I got two characters, so 1 plus 2 is 3. After that, I'm updating L to 0 and R to 4. These two are again equal, so again my length is modified, it became 5. Okay. Again, after that, I modified my L to minus 1 and R to 5 because L minus minus R plus plus I'm doing. So when this happens, the while condition is breakdown. Okay, this condition is not satisfied. L is not greater than equal to 0. So I have to go out of the loop. So when I'm coming out of the loop, my L is minus 1, R is 5. Okay, so if I want to find what was the starting index of the palindromic substring, it is going to be L plus 1 minus 1 plus 1, which will be 0, and R minus 1, which will be 4. And this is right also. This is index 0, this is index 4, and they are forming palindrome. Okay, that's why L plus 1, R minus 1 is there. So this is how you can proceed and find longest palindromic substring of odd length. This I told for odd length. For even length, you have to do one additional thing here. You will first compare. Rest everything will remain same. This will be I minus 1. This will be I plus 2. For even length, it will be I plus 2. And length will also be 2. But you will get start and this will go till n minus 2th index. Okay. First, you will check midpoints are equal or not. So one midpoint is at index I, other is at I plus 1. If those two characters are not equal, so in that case, you cannot have a even length substring for this index. So you will continue. You'll check for next index. So this condition need to be satisfied before coming to this part. Rest everything will be same. Just add this if condition above this length part and all, above this length L and R thing. Here, what does this mean? The midpoints are not equal. It is I plus 1. So if the midpoints are not equal, we cannot have a even length substring. So we cannot have a even length substring for this index. So let us move on to next index. So I'm continuing. Okay. If this condition is not satisfied, then you have two characters now in your substring. One is at index I, one is at index 2, index I plus 1. Now you compare left side of left midpoint, which is I minus 1, and right side of right midpoint, which is I plus 2. Okay, this is how you will start for even length. Rest everything will be same. This comparison will be same, and this thing will be same. At the end, you'll have a length of longest even length substring eventually. And once you have both the loops finished, you will have a length of longest palindromic substring which is possible. And you can print all characters from start to end index because that will be your palindromic substring that is possible, which is of longest length. Okay, this took a lot of time. This problem was not that hard, but still, Anyone have any doubt in any part, they can ask. And be more responsive, guys. How many of you understood this? Right? Yes. Okay, Tanaya, Nandini, Jhansi, Lalita, Sneha. We have Sheetal also, Gagana, Kanika, Chandana, Pavni. They understood this. Anyone have any doubt, they can ask before we go to next problem. Okay. Okay, let us move on to next problem. This problem is amazing. I mean, very good problem. So read this problem and let us have a timer. Let us finish this problem within 30 minutes or less. Very easy. I guess most of you can solve this one. So it's like having keypad phone, everyone remember? So the keypad have every number corresponding to that. We have characters also. So given a string containing digits from 2 to 9, okay, and return all possible letter combinations that the number would represent. Okay, return the answer in any order. Mapping of digits to letter just like telephone buttons. Like two, if there is two present, it has three options. Either it is representing A, or it is representing B, or it is representing C. T, so D, E, F, and so on. Okay, so you are given a string of digits. Okay, and you have to find all the corresponding combination that are possible, letter combinations that are possible for that digit given to you or numbers given to you. Think about this problem. I'm assuming, like, hoping a lot of answers for this one from many of you. Okay, we got few responses. We first from Sneha. Sir, we take a map, keys are digit. Okay, you'll map key and digits. Sorry, you'll map digits and letters. Okay. Then depending on the input, we take the respective list of values. We find combinations. Okay. Can we use recursive function? Yes, you have to use recursive function because you want to find all possible combinations. Sheetal, can we use multi-value hash map to solve this problem? Yes. Multi-value, like your goal should be to map every digit with corresponding set of characters. So like 2 should be mapped to A, B, and C. Okay. So you have to use recursion and you have to map values, two things. Recursion because you want all possible combinations. Whenever you want to try all possible combinations, you need recursion. Okay, let us solve this problem also. Uh, Again, given a string of digits, okay, and every digit it is mentioned is going to be between 2 to 9 only. Okay, every digit has some letters corresponding to it, like 2 have A, B, C. Okay, Yamini has given one detailed answer. Declare a dial map. Okay. Linking numbers and alphabets. Okay. Declare a empty string vector. Okay. Vector is dynamic array. We need a temporary string and index point on the given input string to map on that dial. Okay. In the recursion function, base condition is this. Push the temp into the result, else find the number and corresponding, run a for loop, push the character of string in the temp and calling recursion with index plus 1. Pop the temp. Seems fine to me. Yamini, good job. Similarly, 3 we have, what are the characters? E, F, G, D, E, F, G, H, I. Okay. D, E, F. So you can use hash map, map, dictionary for doing this mapping. Goal is very simple. Map corresponding characters with the digits. Okay. So 2 will be mapped with ABC. You can have list, you can have vector. Vector is a dynamic array, and map 2 with those characters and all. Okay. List of characters you can have. Okay. Now we'll come straight to the point. We have a string given to us, and string contains digit. So how the recursive function is going to be written? Very simple. We have two options. Either you can move from left to right, or you can move from right to left. So suppose string s is given, which contains the digits. Okay, set of digits which are given to us. Suppose the name is s. We will start from the very first character or very first digit of string, which is present at index 0, and we are moving in this direction. Like from 0 we'll next move to 1, from 1 we'll next move to 2, from 2 we'll next move to 3. Let us see how the recursive tree will be formed. So what was the first example? 2, 3. Okay. So we have these characters map corresponding to 2 and 3. So my S is 2, 3. First, we'll start from here. First character is 2. Now for 2, what options I have? I have three options. Either I can have A, or I can have B, or I can have C. Okay. So we need to maintain one temporary string which will store the corresponding combination of letters till now. So initially that will be empty. Next, if I choose A will be added to this. So my string will look like this. It contains only A. If I choose B will be added. If I choose C will be added. Okay. Next, in next step, where we are going? We are going to next index. What is the element at next index? It is 3. Element in the sense digit. Now for 3, what options we have? We have again 3 options. We have D, we have E, we have F. Okay. So suppose I chose this option of D. So what will happen? My string will get modified to AD. I will get AD. Okay. And I'm going to stop there. No, I'll try to go to the next index. So next index is invalid index. So I can have that invalid index as base condition. So I already have told you in past, when you are moving from left to right in case of arrays or string, you are going from index 0 to 1 and so on. Like from index I, you are going to I plus 1. So here you can always choose I is equal to length of array as base condition, because that is an invalid index and you have to stop at invalid index. So when I am at invalid index, I have a combination of letters. So what I have to do? I have to find combination, all the possible combinations. So obviously I'll be having one 2D string array. 2D string array will be there where I will be storing all the combinations which are possible. So when I am at this stage or I am at invalid index, so I'll take that combination and add to my answer. In my answer, A, D will be added. Okay. Next, I have to, in case of recursion, what happens? Here I am writing base case. In case of base is triggered, that particular substring that's sorry current string that you are having is added to your answer. Okay. Okay, it is answer is going to be vector of string or dynamic array of strings, because we are storing strings only. And why dynamic? Because we are adding values at runtime. So now once base is triggered, AD is added, and after doing that we come back. This coming back is known as backtracking. So we backtrack and we chose the second option. Second option is take this E. So if I take this E, I have AE. When I go to the base condition, I have AE with me. So I'll add AE. And again after that, what will I do? I'm done with this. After triggering base condition, we come back again doing backtracking and explore the third option, which is F. So once I take F, again base condition will be triggered because I'll try to access invalid index and AF will be added. Once I'm done with this, again I backtrack. Now all the options that I'm having is over, is finished. So I'm done with this whole part, execution part for this. So once I'm done with execution part for this, I'll go back. I'll go back because backtracking happens in case of recursion. We have to free up the memory once task of any function recursive call that we made is finished. We have to free up the memory. Once memory is freed, we go back. Okay, that going back is backtracking. So now we are choosing B to be the character or the letter instead of A. So when we choose B, we have this substring now, this string now, which contains B. And again, we go to next digit, which is 3. Again, we have three option of D, E, F. Again, we do the same thing and we keep on adding. Okay, so we will have 9 numbers. Sorry, not numbers, 9 combination of letters. Now, whatever we have seen here, we have to write it in case of, in terms of recursive function. So what my recursive function is doing, it is finding all combinations. So you can have something like this name, finding all combinations. Obviously, I have an index, I have a current substring, and I have my original string, I have answer, which will store strings, final string or combination of letters. What is the base condition? Very simple. If I am going to the invalid index, which is I is equal to length of string. This is invalid index. So this can act as my base condition. Here, what will I do? I'll add whatever combination I'm having currently. Okay, and after adding, you'll return. Here you added one combination. Okay, are we returning anything? No, we are not returning. So void can be your return type of function. Okay, now if this part is clear, I want to rub this. Okay, note it down. This base condition, very simple. So if we are going to invalid index, we have to add current combination and we return. Return means our job is finished. Now go back. Okay, backtrack. Here, what is happening? I'll take, okay, I'll take nothing. Let us leave that. I'll go through all the characters of current digit. So I'm going through all the letters of current digit. Suppose my hash map is there, which is storing all those letters, and hash map name is P. So I'm going through all the letters of which are corresponding to this particular digit. S of I is going to be my digit. Okay. Now what I have to do? I will consider this value. I'll consider this letter. Okay. I'll consider this letter. It is very similar to what we did. First, for 2, I have 3 options A, B, and C. So I am considering this. Considering in the sense you have to add this to your current string. Okay, your current string when you start is going to be empty. Nothing is there. But when you choose any option, any letter, so you have to add it. So you are adding it. And you are adding and moving on to next index. So I'm calling this function again with now modified current substring. Okay. And now once I am done with this, I go to the next digit and all. Once the execution part of this is over, I come back. I come back here and now I want to take B and find all combinations. So now I have to remove this A which I added earlier. So you have to remove this. Okay, before you try this B again. So you'll remove the letter that you added. That's it. This is the recursive function for finding all the possible combination of letters for given string of digits. Okay. If anyone have any doubt, please ask. Okay. No one have any doubt. Great. Moving on to next problem. Hmm, okay, we are done with this. Did we did this? Okay, let me do that also. Okay, I'm sharing this problem. Go through this. This problem is related to trees. Very simple. We have, if you understand this one, you can solve 5 to 6 more variety of this. So you have to basically, what is given? The top view of binary tree is set of nodes visible when the tree is viewed from the top, like what you can see from the top. Yeah, when you are reading this for the first time, you'll find it strange, but let us finish the problem statement, then you'll understand. Given a binary tree means at most two children are possible. Print the top view of it. Top view. Remember, there are few different type of views: left view, right view, top view, bottom view. Okay, so that's why I told you, if you understood this, you'll understand. You can solve rest of them. Okay. The output node can be printed in any order. Output node can be printed in any order. Okay. A node X is there in the output if X is the topmost node at its horizontal distance. Okay. So there is some concept of distance here. Okay. So you'll assume your root node is at distance 0 horizontally. If you are going left, means your horizontal distance, you're going one horizontal left. So from 0, if you go 1 unit left, you'll go to -1. And right basically means you are going 1 unit right side. So from 0 going right will give you 1, going left will give you -1. Now you are at -1. From -1 going left. Left means 1 unit on left side. So from -1, if you go 1 unit left side, it will be -2. From -1, if you go 1 unit right side, let me have some space here. Okay. So from -1 going 1 unit right is again you will be at 0. Okay. Again. So 3 is nothing but at 1 unit distance on right side, on positive side. So if for left child you have to go 1 unit left. So from 1, if you go 1 unit left, you are at 0. From 1, if you go 1 unit right, you are at 2. Okay, so these are like corresponding distances, horizontal distances, and how you have to find them. If current node is at x distance, left child will be at x minus 1, right child will be at x plus 1. You understood till now? This is very important. Once you understood this, you can easily code this now. What is written? A node x is there in output if x is the topmost node at horizontal distance, at this horizontal distance. So topmost in the sense level wise. One is at the top. Okay. Next we have 2 and 3. After that we have 4, 5, 6 and 7. So in this order, this is at the topmost. This is at the second topmost level, third topmost level, and so on. Okay. So we have three nodes which are present at 0, but we will only print one because it is at the topmost level. Okay. Similarly, we will print 2, we will print 3, we will print 4, we will print 7. So output is going to be 1, 2, 4, 3, 7, like any order you can print. So we have 4, 2, 1, 3, 7. So this is what you have to do. You are given a binary tree. You have to print nodes which will be visible from the top. Okay, if you look at it from the top side. Now, how you will solve this one? I hope you understood the problem. Now, it is purely on implementation how you will solve this. Yes, Yamini, I'll explain. Okay, so I'll explain the problem statement one more time. Very simple. We have a binary tree given to you. So binary tree is there. Binary tree means any node is going to have at most two children. Okay. One is obviously going to be left child. Other one is right child. Okay. Now, suppose this was the tree given to us. Was it this? One, two, three, four, five, six, seven. Okay, it was starting from one. So I have written zero. Okay, leave it. So now they want you to print top view. One thing you have to understand, if there is one node which is having some horizontal distance x, we'll come to that. If there is a node, suppose a node A is there, it is at horizontal distance x. X can be positive, x can be negative. Suppose x is some value, okay, some horizontal distance. Here in this problem, we have to assign some horizontal distance to every node. Okay, some x is there. So left child will be at x minus 1 horizontal distance. Left means we are going left side, one left. So in horizontal number line, suppose if I am at distance 5, left, going left means I'll go at 4. 4 is nothing but my current value minus 1. So we go 1 unit left. So left child will be at x minus 1. Right child will be at x plus 1 horizontal distance. This is very important. So this is left child and this is right child. So based on that, now how we find the horizontal distance for every node? So we start from the root node and root node is assigned with value 0. We say that root node is present at origin. Okay. So root node is at 0. Now, now we can find corresponding horizontal distance for 1 and 2. 1 is left child. So 1 will be present if we go 1 unit left. So if I draw the number line like that, we have 0 here. 1 unit left means I'll go to minus 1. So corresponding horizontal distance of node 1 is minus 1. For node 2, it is going to be 1 because I'll go 1 unit on right side for right child. Similarly for 3, 3 is nothing but left child of 1. So you'll go 1 unit left again. So it will be minus 2. For 4, 4 is nothing but right child of this node 1 which is present at minus 1. Right child means you'll go right side 1 unit. So right side 1 unit means minus 1 plus 1 0. Now for 1 again, like for node 2, 5 is on left side. So left side means you have to move 1 unit on left, which is 0 again. 6 is right child, so you have to move 1 unit right side. So it will be 2. So I have written all the corresponding horizontal distance for every node. Till now, anyone have any doubt? Okay, Tanaya have given one approach. I'll come to that. So till now, if it is clear, great. Now, what we have to do is we have to print right, sorry, top view. And how we are printing? We are printing topmost node at every level, not level, for every horizontal distance, topmost node. So this is the topmost node. So we are coming down like this. Nodes which are present here are considered to be at top. So this is the topmost This is the second topmost and third topmost and so on. So this is at the bottom. These nodes 3, 4, 5, 6 are at bottom. So nodes which are present at horizontal distance 0 are 0, 4 and 5. You can see 0, 4 and 5 have horizontal distance 0. Out of these three, which one is present at higher level? So at higher level, 0 is present, so 0 will be printed. Okay. Now for distance 1, which all nodes are there? We have only 2. So 2 will be printed because only one node is there and that will be at highest level. Next, we have distance minus 1. How many nodes? Only one. So 1 will be printed. Similarly, for minus 2, we have only one node. So 3 will be printed. Similarly, 6 will be printed. So that's how you'll print those nodes. Okay. If you have multiple nodes at same with same horizontal distance, in that case, you have to choose the one which is at higher level. Okay. And how level is decided? So root is at the topmost level, and as we go down, level also decreases. Okay, this you have to keep in mind. Now, is this clear, Yamini, or you have any doubt? If still you have doubt, you can ask. Okay, clear, great. Sir, Tanaya is saying we can start from root node. Okay, print the root node and keep printing the left values of the node. Once we reach the leftmost leaf node. Okay, we again start from the root and keep printing the right child value till we reach the rightmost node. Tanaya, there is few mistakes here. Consider this case. So in this case, nodes that are going to be printed is this node is at 0, this at minus 1, this at 0, 1, 0, minus 1, minus 2. This at 1, 2, 3, 2, 1, 2, 3, 4. So nodes that will be printed is this node, this node, this node, this, this, and this. So you cannot keep on going left, 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 left. If you maintain two things, your job is done. If you just maintain two things, what are those two things? Tell me. If you have two things, one of the thing is horizontal distance. And second thing is level. Think about this. Very good problem. Tanaya, you understood which edge case you are missing? Which case? Not even edge case. Okay. Hint here is bread first search. Yeah. Sorry. Those who know how to do bread first search. Yes, Yamini, we implement bread first search using Q only. Okay, so I have randomly drawn one binary tree. So for this tree, tell me the nodes which will be printed in case of top view. Okay, Tanaya have written 1, 2, 12, 14, 3, 4, 6, 1, 1, 2. Is she correct? Let us write their horizontal distance. This is at 0, minus 1, 1, 2, 1, 3, 2, 1, 0, 2, 3, 4, then 2. This is minus 1, this is 0, minus 1, 1, 0, minus 1, minus 2. Now tell me 1, 2, 14. Okay, how many also said 1, 2, 14, 3, 4, 6, 4, 6, 1, 1, 2. So 12, Tanaya, 12. 12 should be printed or not? Okay, no. Yes, so let us remove 12. Now, is it correct? This we are printing. At this is present at 0 horizontal 0 horizontal distance and at the topmost level. This also will print because this is present at minus 1 distance, horizontal distance, and at very high level. This also will print. Next, do I need to print this? No, we already have a node which is present at higher level at this distance. Do I need to print this? No, because we have one more node at higher level, okay, which with this distance. Do I need to print this? No, because 2 is already present at higher level. This, no, this, no, this, yes. Because minus 2 has not occurred till now. This is the very first time we are having this horizontal distance. Okay. So this will be printed. Now here we have 5. 2 should be printed. Yes. 5, it should be no. 3, yes. Like this should be printed. Yes. This, no. This, no. This, no. This also no. 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 Yes. Approach is very much simple. We start from the root node. I'll move all this. We start from the very first node, root node. Okay. Now there is chances of collision. Okay. We start from the root node. Root node is starting from horizontal distance 0. Okay. Now we'll also use one hash map where we will store which all horizontal distances are already used. We will mark them. So 0 is not used till now. So I'll mark 0. 0 is used. I'll print this node 1 because at node 1 I'm getting a new horizontal distance that is 0. Okay. Next, I'll go to its children's. Okay. This children is present at -1 horizontal distance. This child, right child is present at 1 horizontal distance. Now, when I go to this node 2, I see, okay, horizontal distance is -1. Is -1 already used? No. So -1 I'll mark. Okay, it is occurring for the very first time. I'll mark and print the node. Next, for this node 3, I'll check the same thing. Is this horizontal distance already used? Used in the sense I have printed a node at this distance. No, this is occurring for the very first time. So I'll mark it first. Okay, and then I'll print. Okay. Next, I go to their children's. Now 9 is present at horizontal distance 0. 4 is present at horizontal distance 2. Now 0, I check. I go to node 9. I check horizontal distance is 0. Is 0 already used? Yes, 0 is already used. So I cannot print this node 9. Okay. Already used means some node at higher level is already present at this horizontal distance. Okay. Same, I go to node 4, I check. Is 2 already used? No. So I will print 4. Okay. And mark it. Next, we go to their children. We have 12 and 10 for 9 and 5 and 6 for 4. So they're corresponding based on our corresponding like the horizontal distance of current node. We can decide left child will be at 1, right child will be at 3. Here also left child at -1, right child at 1. Now when I am at node 12, horizontal distance is -1. Is -1 already used? Yes. So I cannot print 12. So why we have written 12 here? So 12 cannot be printed. Okay. Next, we go to 10. Horizontal distance is 1. 1 is already used. So we cannot print 10 also. Next, we go to node 5. 5 horizontal distance is 1. 1 is already used. We cannot print 5. We go to node 6. Horizontal distance is 3. Is 3 used? No. So we'll mark it as used and print this node 3. Sorry, node 6. Sorry, node is 6. So we print this node 6. 3 is horizontal distance. Similarly, we proceed. So whenever we are getting a new horizontal distance, we are marking it and printing the node. And this way, when we propagate or go to all the adjacent nodes once at a time. This strategy is breadth first search strategy for traversing through a tree or graph. Okay. So from here we'll go to its child, which is 11 present at 0. This is -1. This is -2. So -2 we are getting here for the very first time. So 14 will be printed. Similarly, 7 is at 2, 8 is at 1, 17 is at 0, 19 is at 2, 10 at 3, and 112 at 4. So this distance 4 is occurring for the very first time. So I'll print it. Okay. So that's how you have to do this. Now, do you want me to write pseudocode for this or you want to try on your own? We have to use Q data structure. That is fine. Now tell me in chat. Any doubt first of all before going to the pseudocode? Any doubt in this? How we will print the top view? Okay. Now, do you want to try on your own or want me to share the pseudocode for this? Write the pseudocode for this. Arey, nobody is saying anything. I assume you want to do on your own. Okay, so this is your homework. And I think this problem is available on LeetCode also. Just search for top view of binary tree. Okay, and try to do on your own. Although video recording will be shared with you, if you have any doubt in logic part, you can check it. Okay, I'm winding this session here only. If anyone have any doubt, they can ask. Okay, anything you want to ask, you can ask. Hmm. No one have any doubt. That is strange. Okay, guys. If no one have any doubt, I'm closing the session. Bye. Good night. And thanks for joining. Most welcome, Tanaya.